This is Zach, the PCB designer. Now that all the parts have been placed on the board and my colleague Wilfred has finished defining the plane shapes, I will begin the process of fan out and breakout of the 4 DDR4 chips here. I will start by fanning out the first DDR4 chip here on the left. Taking a look at the pad entry settings in Editor Control, we can see that the VIA and pad functionality has been enabled for the round pad used on the DDR chip. I've also set up a scheme in the Net Explorer that has filtered out all of the power pins on the DDR chip. So selecting my scheme in the Net Explorer and using the filter for net selection, I can area select all of the pins on the first chip, and only the non-power pins will be selected. In this case, the purple and yellow pins are the power pins, so they remain unselected due to my pre-configured scheme. Now using the fan out command, F2, I can automatically fan out these pins. And we can see for all of the green pads, the signal pins, that a VIA and pad has been placed. The light pink pins here are the ground pins. Notice that the ground pins were not fanned out during the area select fan out command. The reason for this is that they are already connected to a ground plane on the top layer. So turning on the planes visibility, we can see here this pink ground plane on the top layer, and it's already connected to all of the ground pins. It is critical to connect these pins to all reference ground planes to ensure a proper return current and minimize mounting inductance. So even though they're already connected on the top layer, we're going to go ahead and place a VIA from layer 1 to layer 5. So I'll place the 1 to 5 VIA on one of the ground pins in order to connect it to layers 3 and 5 ground planes. So using the Add VIA dialog, I'll select my VIA and the VIA span. And then I can place my VIA on the pad, enabling hover snap to get the VIA directly in the middle of the pad. So the VIA 1 to 5 VIA has now been placed on one of the ground pads. Now I can use the copy circuit functionality to paste this VIA to all the other ground pins. So turning hover snap off, I'll select this VIA and use the copy command, and then with my net filter still enabled, area select the rest of the pins. And we can now see that the VIA has been placed on the remaining ground pins. So the VIA and pad fanouts for the first DDR chip have now been completed. Next, I will manually fan out a few of the power pins on this first DDR4 chip. Unfilter my scheme, and using the plow command, I'll manually fan out a few of these power pins. We turn the planes on here in the display control. Notice how the VIA pads automatically clear or connect to the defined plane shapes on the board. This P1V2 power pin that I fanned out created an automatic clearance. This is due to the dynamic definition of the planes. A plane will automatically connect to a route object such as a VIA with the same net, as in this case, the P2V5. I fan it out and place a VIA. This VIA automatically gets connected to the plane with the same net. And similarly, as we saw, the dynamic plane will automatically provide a clearance from route objects with a different net assignment. In this case, the P1V2 net provided a clearance from the P2V5 plane. Now I will break out the pins of the first byte lane on this chip. Going to layer 2, we can turn on our net lines and mark our byte lane nets in the Net Explorer. Now we will manually break out this first byte lane. The rule areas previously defined come in handy during this fan out and breakout stage by allowing relaxed physical constraints and smaller trace widths within the rule area. The yellow box seen here is the rule area surrounding the DDR chips, allowing us to have a smaller trace width within the rule area. Notice that the trace width returns to its original constraint once it reaches the threshold of the rule area. The breakout of the first byte lane has been completed. Let's return to a few of the discrete components. I will manually fan out a few of these discrete components and show the Expedition via merging capability. So fanning out this power pin of our capacitor and placing a via, and fanning out the same power pin on another capacitor. Notice how the vias will automatically merge. You can see that since these two pins shared the same net, that the via automatically merged since we had the settings enabled. The via merging capability can be advantageous for signal nets in order to reduce the number of vias in the path for signal integrity. And for a power net, we would likely require multiple vias to distribute high power and lower mounting inductance. So we could explicitly prohibit via merging for power nets. In this case, that might be what we want to do, so we could delete this via and simply connect these nets here. Maybe we want to have separate vias for each one of these components. In the via merging settings, we can prohibit via merging for specific nets. In this case, we could prohibit via merging for the P2V5 net, as well as other power nets in the design if required. Now that fan out and breakout has been completed on the first DDR chip, I will use the copy circuit command to copy the fan outs and breakouts from the first chip to the remaining 3 DDR chips. So area selecting my fan outs and breakouts. Can use the copy circuit command and copy these to the remaining 3 DDR chips. This can save me an immense amount of time since I already know that the fan out and breakout for the DDR chips will be identical. So I simply completed the work on the first chip and used the copy circuit command to copy to the rest, and my job is complete. Few manual things we may want to change up here. Merge the vias. So I've now completed the fan out and breakout process for all 4 of the DDR4 ICs on the board. The SIPI engineer Rory can now begin defining the decoupling strategy and analyzing the power distribution using hyperlinks. Once this analysis is complete, Rory can make suggestions to the hardware engineer Nicole, who will make any recommendations to the schematic and forward annotate those edits. Once a forward annotation bundle is ready, I will import those changes back into the layout and update the parts.